Good afternoon, everybody, and welcome to Zahn Academy 2026. I'm Fran, and I am Zahn's education manager. And I just want to start out by saying thank you so much to all of you out there for being so wonderful and just being avid learners with us here at Zahn Academy. We had a very successful 2025, and that's because of all of you for trusting us with your education. And we really want to thank you from the bottom of our hearts, and that's why we're back here in 2026. And we're looking forward to a very, very successful year full of new innovation and workflows. And you're going to get that all here with us every week here at Zahn Academy. So I just want to let you know that we have a very special person here joining us today, Alex DeVos, who is one of our technical support engineers. And he is just a whiz with 3Shape. And everywhere we go, Alex joins us and you know what, he has trained so many of our customers, and everyone just wants him back, wants to learn tips and tricks from him, wants to learn about the new RPD workflow. And that's why we have him back. And he's our first speaker of 2026. So, Alex, thank you so much for taking your time away from doing all that technical support that you do for us here at Zahn and being agreeable to join us here at Zahn Academy. Alex will be with us for the duration of the hour and will be taking questions at the end. So if you have any questions for him, please type them in at the bottom of your screen. I'll also be launching a couple of poll questions, so we'd love for you to be interactive with us. And I'm going to start with one of those right now. I'm going to launch our first question. So if you wouldn't mind answering, do you use 3Shape to design your cases? So just want to know basically who here is designing in 3Shape and who is not. And Alex, the responses are coming in. And of course, we do have a lot of 3Shape users here, but we also have quite a few that aren't. So we'll give that just a few more seconds,
Okay.
and I'll be able to tell you what the results of that.
Yeah,
Okay,
thank you for
so
that, Fran.
yeah, so 73%
Hmm.
are 3Shape users and design their cases in 3Shape, and 27% do not as of yet. So that's good. You're in for a treat.
Alrighty. Then yeah.
Thank you.
Then yeah,
Thank
don't
you so much,
be
Alex. I'm going to turn this over to you.
yeah, thank you a bunch, Fran. So today we're gonna be focusing on partials in 3Shape. We're gonna go from scanning forward. So I've got a couple scans already captured, but we'll take care of the design work, and we are going to look at a bit of the nesting as well to get it ready for printing. As we go through, again, definitely jot down any questions as they come up, and at the end, we'll take a look at all of those and address anything you need. Um, to start off, I do have 3Shape open here, and I want to discuss the ways to set up these types of cases. So I'm going to start a new case in 3Shape. For this, there are a couple methods of doing this, specifically for flexible partials. And I want to discuss both of those, though we'll only be going through one of them for today's webinar. So to start off, I'm working on my upper arch, so I'm going to select one of these teeth numbers on the upper arch and go to the removable section. This is all you would need if you were doing just a traditional partial framework, that you were planning on either milling or printing in a castable material to then do traditional investment in casting. But for today's workflow, we're going to be focusing on flex or acrylic partials. For that, there are a couple options. To finish setting this up for a flexible partial, in addition to the removable, I also need to select the specific teeth that I'm replacing. So wherever the teeth are extracted, I'll label those numbers and add this option under the anatomy section, artificial tooth. This will mean that any tooth we design will be separate from our base. It'll just have a socket that it fits into. Otherwise, for traditional metal frameworks, there are other options in here, like I could set it up as a pontic if I wanted the teeth to be metal part of the framework as well. But The other workflow that we aren't going to be doing today is using the denture workflow to design a flex partial. There are some advantages to this, but personally, I find that it makes certain aspects of the design more difficult. So we'll be using the other workflow for today's session. With this setup, you just select the tooth numbers you're working on as the denture base, and we use the same option in the anatomy artificial tooth. The main advantage that the denture workflow has is we are allowed to bridge teeth together so that they're all a splinted piece that fits into a single socket. We aren't able to do that with the partial workflow we'll be using, but there are a lot more advantages to our design as we go through. So again, there's a couple, like most 3D softwares, there's a couple ways of going about most things, but we'll go through with whichever you prefer. For today's session, I have it opened up already, so we don't have any time to wait for opening. Um, for design, we've got our main workflow up here that we're going to follow through, where it, for the most part, uses the traditional metal framework workflow, but we'll be able to skip these steps that are not relevant to the partial design for the flex partials. To start off in this prepare section, there's just a bunch of tools for cleaning up our scan data in different ways. This one in particular came from model scans, but if you're working with an intraoral scan, you might use this a little bit more to trim away parts of the edges of the scan that were a little bit messier. The first options here I don't really need to do much at. There's some refine tools where we can have the software automatically identify and fix problems that it thinks it sees in the scan. And sometimes I like to do that on intraorals, but I don't often need to do that for models. So we're just going to click next, past those two steps. The next one, occlusal alignment, shows up during most types of designs, though it's not as relevant during certain types. In particular for partials, it doesn't really make much of a difference wherever I move this tooth chart around. But on the designs where it is relevant, like denture designs or model designs, we generally just want this roughly level with the arch of teeth and mostly centered in terms of where the tooth chart is. During the sculpt steps, this is where we can modify the scan data, and you can use this for a couple different things. Um, if you're working off of a pre-extraction scan, you can virtually extract teeth with this step. That'd be with this tooth extraction tool, where you can just draw around what you want to cut out of your scan. And once you're happy with that outline, you hit play to remove the bulk of the material. Additionally, if there's any defects in the scan, whether that's a hole or a bubble, you can use this Band-Aid tool to just paint that problem area or multiple problem areas. And once you hit play, it'll delete whatever's red and fill that in with a smoother surface. This is also where you can create a bead line or a post-stem indentation. So if that's something that you weren't able to introduce into a physical stone model before scanning, you could go into this wax knife tool and use its subtract function to remove material at a certain size and strength. So I can just carve in a little indentation by going back and forth over areas. I will say for most milled and printed dentures and partials, the feedback I get from most customers is that it's not as necessary anymore since these materials don't have the same shrinkage as traditional acrylic. So we don't really find we need to create this type of bead line, at a minimum, not to the same degree that you would previously. But I'm going to leave it without it for this case. We get the same option for the lower jaw if we needed to modify the opposing, but we'll continue forward. This next step is related to the teeth that we're going to be designing and placing. In this case, it remembers when I scanned this model where I marked each tooth to be, But if this came in from an intraoral system, you would be marking these from scratch, just following along with whatever number it's pointing to in this note on the left. So we'll do it in order, 3, 4, 5, then 10, 11, 12, 13. These do not have to be exact. They're just so 3Shape has a reference for where the teeth roughly need to load in when we get to that step. Continuing next, we get to kind of, I'd say the first really important step is the survey and blockout. This is where we're essentially choosing the seeding path for our framework. We can see it does have a default direction that it starts at, where we can see how undercut different areas are based on this current direction. One thing I would note is this direction is not a recommendation. This is just whatever angle this model happened to be when it was scanned. So I pretty much always am going to change this in a couple different ways. The best way to get a kind of default seeding path is to look at it from a top view. Just look at the model and try your best to find an angle where you can see as much surface area as possible. And especially because we have some contact areas that are in the anterior, I need to try to make sure I can see as much of that contact as possible, so that I don't wind up with a large gap in between that central and the lateral I'm going to be designing. So I'll have to make some compromises depending on where I want class to be and where my contacts are. Once I think I've found a good rough estimate for where my insertion path should be, I use the Set From View button to make wherever I'm currently looking from the new direction. And I can take a look around to get the lay of the land after that change. In general, for traditional partials, I am okay with them going into very deep areas with the tips of the clasps. In an ideal world, I would have the tip of a clasp going into this dark red area above 0.75 undercut and have the majority of the length of the clasp be in the lighter orange or yellow region, less than half a millimeter undercut. For flexible partials, it will vary a little bit depending on how much flex that material is. For example, there are milled materials like acetal that have a lot of flex to them that are very forgiving for this. And there are printed materials which have some flexible options, but they're on the more rigid side. They aren't quite as flexible as traditional materials like acrylic. So in here, we're going to make slight adjustments depending on where I want to change it. I still see a good amount of undercut here, which I want to try to minimize as much as possible. And I don't have to constantly do it from that top view. I can make small adjustments using these arrow keys just to tilt a little bit at a time. And you can decide how much it's tilting each time you click. So just 2 degrees at a time to tilt, just by small increments until I see smaller undercuts in that area. Obviously, by decreasing the undercuts on one side, I'm increasing the undercuts on the opposite side. So you'll have to try to find some compromise between this. Just going back and forth, tweaking it as needed to try to get things to the best average for where you want your undercuts and retention to be. So let's say I'm happy with that. I think that's fairly good for now. It's a little heavier on this side, but with the way these teeth are in the arch, there's no way to really completely avoid that. But once I'm happy with my seating path, I continue next, and it's going to automatically block out all undercuts, no matter how shallow. And that's with this slider here to show us what it's blocked out following that seating path. So at this wax trimming step, now that it's automatically blocked out everything, we're going to go in and remove the block out wherever we need that retention. Whoops. So we'll just make that a little transparent so I can see the colors of the undercut depth. And I can go in with the subtract tool to remove that blockout material. You don't have to worry about the subtract tool going too far because it will stop once it hits the surface of the model before the blockout happened. So I'm just subtracting where I plan on having a clasp run, and any of the areas that I don't want the clasp to engage with, I just come back in with the smooth tool to fill in and block out just the deepest areas. You can use the add tool for this as well, though the smooth tool usually gets most of what you need. So I just go around continuing that reduction. The main areas where I do not want to ever reduce are the interproximal sides of the teeth, since this is an area that's not going to be able to flex, so I'm going to leave that blocked out. Just to make sure it has a clear path in and out of the mouth. If you plan on putting a rest seat, we can put it partway up on a teeth later on. And if I want that to engage with at least the shallow undercuts that are less than 2.25 millimeters, that can be okay. So I can subtract that to give it a little bit more retention where it might not otherwise have it. Otherwise, you can leave that blocked out if you think you have enough retention elsewhere. But once you think you're happy with your blockout, you can continue next. And it's going to take us into the crown design portion. If anyone's worked with 3Shape for fixed restoratives for crown and bridge workflow, you've probably seen this layout before because it is the same exact set of tools. If we were using the denture workflow to design this, we would have far fewer tools available, though we would be using specific denture libraries. I can go in and pick different libraries here as well, whichever ones I think fits this patient the best. There are different options for anterior versus posterior teeth, but we can pick whichever one we think works best. We'll go with this for now. From here, I'm going to try to quickly run through a rough crown placement. I'm not going to spend as much time as I normally would on this, just for the sake of just covering the main tools for this workflow, making sure I cover everything in time. But in general, if you wanted a review of my overall crown design workflow for using all of these main tools, if you look on Zahn's YouTube page, we have a lot of good videos on 3Shape design that cover a lot of these tools that are used throughout 3Shape. But I'm just starting with the transform tools, just resizing the teeth to fit our area a little bit better. Resizing, scaling, tilting. And I can also pull up my opposing to get an idea that I've got everything pointing in the right directions, hitting where it should be. So we'll say that's close enough for now for that side, and we'll get this side lined up a little bit better. For the transform tools, there aren't a whole lot of shortcuts that we use for this particular tool. The only one is the control key to scale it in all directions at the same time. But in general, most of the time, I'm just tilting or tweaking one side at a time as I adjust each tooth. I started off with the group transform tool that moved all the teeth at once, but in this case, I think it needed a little bit more refinement to get it sized and positioned properly for this arch. I think these premolars have to be a little bit smaller. Additionally, there is a tool I could use since we are working on the anterior to copy the anatomy of the other lateral and canine. I won't be using that in this case, but that tool is located right here for the mirroring function. So for a real case, I'd probably use that a little bit more, at least to start with. So we'll say that's fairly close for now. To make additional changes, I'll use this tweezer or morphing tool to stretch around parts of the anatomy. And while I'm doing this, I like to have a slider that shows me some distances and colors. So all of the colors from red to green are not touching the opposing. They're just getting close. all of the cool colors from blue to purple are not just touching the opposing, they're poking through the opposing a little bit. So it's too heavy in those cool color areas. So as I'm stretching around, I can warp the existing anatomy to fit the area a little bit better. I like using a control key shortcut to reduce material wherever I see those high points of contact. And the main reason I use this tweezer tool more than the wax knife with its plus, minus, and smooth is because this tool is better at keeping the anatomy as you pull it around, whereas the other one tends to smooth out and buff away more detailed anatomies. So I will use that eventually, but only for smaller touch-ups. So this one's much heavier in contact, so we'll stretch that quite a ways down. Make sure all the teeth are overlapping at least a little bit to start with. Make sure we don't have any major gaps. Make sure we have full contact. But all in all, I'd continue making more adjustments as needed, not just for the functional areas like the contacts, but aesthetically, adjusting the contour of the teeth, stretching and pulling around the anatomy to make sure it's not too far off from the existing anatomy that's there. But just in terms of saving time and making sure we get through everything, I'll kind of cut off a lot of the aesthetic changes for the teeth here. But from this point, there are a couple specific things we need to make sure are handled properly for a flex partial. So as these are right now, we've got the undersides of most of these teeth poking through the scan. So it's not just stopping at the surface right now. And there are a couple tools that we'll use to handle this. The first one is an automatic tool that's under this contacts and smoothing. We've used this in other parts of 3Shape to adapt to neighboring contacts or opposing teeth, but there's a tool in here for bridge cases and for cases like this where we can cut the underside of a pontic shape from the tissue. It varies a little bit by material, but if the material needs a certain amount of space underneath the tooth for the socket base, we need to make sure we give that relief with this value. So for example, most printed resins, you need at least 0.5 for a minimum thickness underneath the sockets. So maybe I'll give myself a little bit of extra room at 0.6. If I hit this double play to apply to all teeth simultaneously, you'll see it will cut the undersides how I want, but a downside is it is going to cut the neighboring side as well because it doesn't treat this part of the scan as from any different as part of the tissue area. So I'm going to undo. I will still use that automatic tool, but I can only really use it at that high value for the teeth that do not have a neighboring contact that's a pre-existing tooth. So I'll click on this tooth and just do a single play to apply just to those middle teeth. And same thing for this one tooth over here. For the remaining teeth that do have a contact, I am still going to use the automatic tool, but to a much smaller degree. I still need a little bit of space for the base to wrap around the tooth for the socket, but I'm going to go much tighter, usually somewhere around a tenth or 1 point or 0.15. And this I can do the double play because it will not make things that are already further away tighter. This is still at the 0.6 I set it to earlier. It's only affected things that were tighter than 0.15. So we've still got a gap there, but it's much smaller than it would otherwise be. To then adjust the underside of these teeth to make sure they are also at the 0.6 value, I'm going to adjust it the rest of the way using the wax knife. And when you're using the wax knife with its add, subtract, and smooth, the add and subtract have some extra features beyond just the size and strength. So normally, We've got our area of effect for this circle size, shift and scroll wheel to reduce material right now. And we've got a strength slider if you want that to be a little bit more controlled. You set it to a weaker strength. But for the underside, there are some limiters we can put on this reduction tool. We can tell it that anywhere within the scan and blockout wax, we can tell it to stop adjusting if it's past a certain distance. So we'll plug in that same value, 0.6. And just to show what that looks like, I'm going to use the subtract tool, and it doesn't matter how strong it is, because once it's at that distance, right now I'm holding down left click, but it's no longer changing. I can reduce, and it just hits a drop-off point once it hits that 0.6 distance from the scan. So this way I can very specifically make sure the underside of the tooth has that 0.6 value, but the mesial and distal contact sides remain tighter. So we'll reduce that area. It is going to leave behind sharper edges, but we are going to smooth all those out in a minute. So we'll just go around to all of these contact teeth with a high circle size and strength, just reducing until I see it stops changing on the underside. In older versions of 3Shape, you can still do this, though it might not have this limiter tool. That's why we have this color map tool for distance on, so you can tell when things are a certain distance away from the scan. But on 2014 and higher, I believe they added this limiter to the partial workflow. But now that I've reduced that material, I'll turn off this limiter, and I'll go back to the smooth tool to clean up the leftovers, just at a more medium size and strength to smooth away these sharp corners that I've made. So just reduce those overlaps a little bit. And because I am making a good number of changes in some of these areas, after I've smoothed out, just for good measure, I'm going to revisit that automatic cut to that 0.15 value from earlier, because the smooth tool can do a combination of adding and reducing. So I just want to dot my I's, cross my T's. Another thing that you can do for partials that is not possible for the denture workflow of this, you can create some pins on the inside of these teeth for retention, just so you have more surface area to bond the teeth into those sockets. The way we go about that is we can use the attachment tool here, and we're going to use some holes in the attachment. You can do this whether it's rectangular or a circular pin, whichever you prefer. The main important thing with this is it should always match the insertion direction we set earlier, since that's also the direction the teeth are going to fit into the sockets. So I'll make my teeth a little bit transparent, pick whichever tooth I want to place that socket on, click to place it from the underside, and then adjust it with the same sliders we use for transformation, just shifting it around, growing or shrinking, raising or lowering. Whoops, did not mean to click delete. But once I think I'm at the appropriate size and position, poking out of the bottom of the tooth, I'd go with that probably. You'll hit the play button at the bottom here, and it will cut away wherever that box was intersecting with this. And as we go forward, when we design our sockets, it'll just have a pin sticking up into the tooth from the socket as part of the base. I won't apply that to all the teeth here. I just want to show that option as an example. The last thing that's required for this design step is making sure that these teeth are not overlapping each other too much, so you don't have to adjust those contacts between them as much. For that, I'm going to use this plane cut tool. I do want it cutting between teeth, and I want it to be zero spacer in between the teeth. So I'll just find a top view where I think I can see that intersection the best. And just left click and drag a line through that intersection to cut between those units. And I'll just repeat that for all the overlaps between every tooth I've designed. But other than that, obviously there's more for this case I could do to clean things up aesthetically. But in terms of the overall workflow and function, that's everything we'd go through. But at this point, we'll say we're happy with the tooth design. And from here, we're going to go forward and design the base of our framework, or of our flex partial. Because we're doing this under the RPD workflow, it does include all the same options that are used for traditional frameworks. So we've got options for retention grids, major connectors, clasps, and the finish line. Though the only thing we're actually really going to be using for flex partials is this major connector section. Even though I haven't done anything at this retention grid step, the software will allow me to skip it and continue next if I need to. But just so you see what's involved with some of these tools, this retention grid just involves drawing the outline where you want that grid to be and hitting preview to see what it looks like at the current setting. So it just adds a grid using this hole pattern that's selected, and it'll add a resin gap underneath. There are other patterns we could use. If I switch to a rhombus pattern, it'll be similar to our more traditional grid, and you can also adjust where the pattern is being applied if you prefer it having lengthwise like that. But again, for this particular case, we're not doing a metal framework, so we'll go without this. I'll just delete that grid. So continuing next to major connector, our first option here is the only tool that we're going to be use. This is the same one used for traditional metal major connectors for upper arches. But in here, it's going to be the outline for our entire base, clasps and all. You could add the clasps at the next step with the clasp tools, but I find that it winds up looking a little bit cleaner if you draw it all at once at this step. So I'm just going to left click and draw my outline all the way around. If I make a mistake or see something I want to change after I've clicked it, I will have to hold off and wait until the line is closed. So I'll draw these clasp shapes. Let's say I have a misclick here. I'm just going to ignore that and continue onwards. Draw wherever I want the edge to be, and at the very end, I'll come back and fix that misclick. For the clasp size and thickness and how much it tapers, it will vary quite a bit from material to material. Some tell you it needs to be certain thicknesses or widths at different portions of the clasp, from the tip to where it connects to the rest of the base. But that's something that's specific to each material. There's some general guidelines that I try to follow, like trying to have it be at least, I think, 2 millimeters or 3 millimeters at the widest point if possible before it starts tapering down to the clasp shape. But it's something that varies quite a bit from material, so you'd have to look up your own. I'll pull up one in a minute, but every manufacturer that produces resins for printing has what they call IFU, or instructions for use, that will have details like those material thickness requirements, along with other manufacturing instructions as well. But now that I've made my way all the way around, I click my first dot to close the line, and now I can go in and clean things up, moving around points where I want them to be now that I've got a better lay of the land looking all the way around. Normally, if this were a metal framework, I'd of course let the clasp be quite a bit more narrow, but for flex frameworks, the material needs to be a bit bulkier. I can just delete this point to get rid of that. And continue tweaking and adjusting this until I've got the overall shape I'm looking for. Another thing to note that I did as I was drawing is on all of the contact areas for the teeth. I did try to have this raised up a little bit. I don't generally want it to go all the way to the marginal ridge of the teeth, but I just want it to be enough up the length of it so that the socket is going to wrap around the tooth itself, not just leave an open edge on the sides. But I think I'm mostly happy with this outline, so we'll continue forward from here. But once I'm happy with that, the only setting I'm going to adjust over on the left is the substructure thickness. We are going to bulk this up more than this, but at this step, the highest value I can plug in is 1.5. So we'll let that start at its thickest setting, since most acrylic or denture resins that we use for this typically want your general thickness to be somewhere between 2 to 3 millimeters. So we'll let that apply at the highest value I can here, and as we continue forward, I'll bulk that up later. But for our remaining steps at this RPD's design stage, we've got tools for adding clasps or minor connectors, doing some sculpting, and adding a finish line. But all of these we don't necessarily need for this workflow. There is a sculpting step that I will use, but it comes after this one. So for this one, I don't need to create clasps, but if I was using that tool, it just involves clicking the button, drawing the center of where a clasp should be, and then using some shortcuts to adjust the size, namely Shift and scroll wheel and Control and scroll wheel at each section. So you could taper down however you want. Again, not that I'm going to be doing that for this case. But continuing next, I'll skip past these 3 steps. Again, I will use sculpting tools, but I have better access later on. So I'm going to skip this one. And I don't need to create a finish line since I didn't create any retention grids. So now we're most of the way. We're just about at the end where we're going to finalize everything. We're at Sculpt RPD design, where I'm going to finalize the base. So for this, to start off, I'm going to use the smooth tool to clean up all of these kind of harder surfaces that we see all around the edges. So I'm just going to give myself a cleaner canvas to build on top of by smoothing that out. And I'm going to be adding a lot of material to bulk things up, both for thickness and for aesthetics around the teeth for the sockets. So I'll switch to the Add tool, and before I start adding, I want to turn on a visual aid, this thickness map. And when I drag this slider, it might be small through the zoom, but there's a value hovering next to my mouse, and I'm adjusting this to whatever thickness my material requires for the general body of the base. So we'll set that close to 2.5 millimeters. That way, as I'm adding material, once I see it's at the green color again, there's no red, I'm at least above that 2.48 value that slider is currently set to. So I'm at least going to reach that, especially at the central of a U-shaped partial or flipper, since that's where it has the highest risk of breakage. Everywhere else, and as it tapers off to clasps, I'm of course fine with it tapering down to thinner areas. So we'll just go around adding material. Around the teeth themselves, I'll start building up to wrap around for the socket shape and the interproximal areas. First, just add my base layer everywhere to get to my minimums. Oh, I didn't realize I had that so close to that. I think I will actually adjust that real quick. Nice thing about 3Shape is it's very forgiving about letting you go back and forth. 3Shape saves everything you do separately from each step. So even though I went back, Once I go forward, it will still remember everything I did. It'll just reapply it to the adjusted shape. So I'll let this load with that change. I'll continue forward, and then I'll let it reload the sculpting that I did a second ago. So it's just loading down there in the corner. But from here, now that I've smoothed things out and added the bulk of the material, I'll continue adding, focusing around the teeth once this is done. Starting with the interproximal areas, so I fill in any gaps in between the teeth if I didn't design them to be completely overlapping. And for this, I like to have the teeth a little bit transparent so I can see just the shape I'm modifying in between them a little bit better. Just building up all of these interproximal areas. Additionally, that I find makes it a little bit easier for if you need to add festooning to the buccal sides. Having that high point there already makes it a little bit easier to just add in front without accidentally adding further behind where you want it to be. But in general, even if you aren't doing a more detailed, like festooned appearance, I still add those areas and then fill in around these teeth as needed. I'm doing this mostly with a very large circle size because that tends to keep things smooth. It's adding over a wide area, and because it has a slow transition over that wide area, it stays fairly smooth. But if I need to refine things, I could use a smaller circle size with the subtract tool to get the contour shape exactly to where I'm looking to have it. And you can use a smaller size to add the festooning I mentioned, just at a weaker strength. But again, I'm not going to add this all the way around for this case, but that's generally what you could do as long as you have enough length below the teeth to create that. On the lingual sides, I am going to continue adding more material, though there's a limit to how high up you can go. You generally don't want to go above the height of contour of the teeth because it will add a little bit extra space around the socket because it's removing areas that create undercuts so that the teeth fit perfectly into the sockets without you needing to adjust. So we'll just continue adding to wherever it looks like we'll have a height of contour. I don't think I'll be raising too much more for these teeth. On this one, it looks like it's already too high past that height of contour, so I might reduce a little bit, but we'll see that in a second when we create the sockets. I think those are already good. We'll just add a little bit back here and add around the buccal side as well. And then fine tune it with smaller tools with the minus to remove material as needed to get the exact contour you're looking for. But let's say I'm happy there with the shape of the base. The last thing that may vary a little bit depending on manufacturing method is the tip of the clasps. For printing these clasps, you should be able to print this even though it's tapering down to a fairly thin point. But for milled materials like acetal, you generally need the clasp to be a lot bulkier, at least during the milling process. So I might, during design, have this really bulky, but after it's done milled, I'll put this on the model and grind this clasp down to a sharper taper. So it just depends on the material, what requirements are there for how we handle the tip of the clasps. For printing as well, I personally do like having a bit of extra bulk there too, just so it's a little bit safer during the printing process, but it's mostly necessary for the milled procedures. The next thing are a couple mostly optional things. If we had created the post in a tooth earlier, I do need to make sure that post is fully filled in inside this tooth. So I'll continue using the add tool with a smaller size until I see that cube shape is completely filled in and hidden. Even though I'm not adding above the surface of the tooth itself, that's all hidden on the inside. I just need to make sure the that pin fully reaches the top of that socket inside the tooth. Additionally, if you're printing out of a material, one downside to printed resins right now is they are monochromatic because they come from a liquid. We can't really add any gradation to them. But some materials that have some translucency to them will naturally have some varied coloration, so it won't look as flat. But if you are working with a material that does have a fairly opacious color to it, you can still break that up by adding some surface texture with the stippled wax tool. The option in here that has denture in the name adds what I call a pockmark texture, where you can decide how deep that pattern is applied. I'm going to make it extremely shallow, just 20 microns. But you paint where you want that pattern to apply. Get that color map off. And you'll hit play to have that apply to add a little bit of texture there. Another one I like both for partials and dentures is these ones that have type 1 in the name. This adds a vein texture to the surface, still at a very small value. And again, just to break that up a little bit, and if I don't want that to be as apparent in certain areas, I can continue using the sculpting tool to just smooth out specific spots here and there to make that a little bit more randomized. But again, not required all the time, but some materials it can make it look a little bit nicer. And then the last optional thing here is adding a name. For printed materials, you can add an engraving into the surface, but for milled materials, the milling burr is not going to be capable of that. But you can type in whatever you want, usually just the patient name. Hit the plus sign and decide where you want the first letter to be placed. And then once you click to place that first letter, you've got a circle to rotate that as needed. Once I think I'm happy with the position, whoops, did not mean to do that. I'll hit this play button to cut that engraving into the surface. And typically, after the printing is done, you'd either, if this were a printed material, you'd take some of the tooth-colored resin and fill it into the socket before throwing it into that final cure. Otherwise, for milled materials like acetal, they have different acetal colors you could inject to those areas, or you could use a clear acrylic. But the last thing at this step that we always save to the end is creating the socket itself. That's under this little joystick icon. And it's this option here, create pockets for teeth. The value here is 1/10 of a millimeter, and that's going to be the space in between the tooth and the socket for whatever bonding agent, whether that's resin or a specific glue for that material. So this will be the main thing you adjust if you find that you need things a little bit tighter or looser for those sockets. I made sure that when I was creating that spacer for the interproximal areas, I chose a setting that was slightly higher than whatever gap I have here so that I don't create any holes. So let's say I want that a little bit tighter than normal, maybe 0.08, and hit play. It'll cut away wherever the teeth are intersecting with our base. And we'll take a look and see if we're happy with where all those edges are. We can kind of see where I had it a little bit above the height of contour, where it's removing this area to make sure it has a clear path of draw. So if I don't want there to be as much of a gap there, I'm going to undo, reduce that area a little bit, and then redo the create pockets. The reason I don't just adjust things after creating the pockets is because it will no longer fit the tooth anymore. The software will allow me to change this however I want. It's completely free to that in that regard. But because of that, it means that if I'm not careful, I can completely distort and wipe away the socket shape where it won't work anymore. So that's why I always save that cut to be the very last thing I do. Even if I need to change something, I undo, make a change, and then redo as needed. But after that, to finalize the case, I'll continue forward. There's another sculpt anatomy step that I don't usually take advantage of. And then at pre-manufacturing, the last final tidbit is another optional thing. For a lot of the printed materials, they do want you to have support bars running on a U shape like this. So I just click a couple points on the posterior regions, and I can add other connector points as well, just so it stays a little bit more secure during the printing process, and so that it is not capable of warping during the final curing process either. Just tapering that off so it'll be easier to remove once the curing is done. But after this, we're finished with our design. I click next and it'll save and exit out of our case. Looks like I'm getting a warning. It's just double checking to make sure no parts of our design are digging into the scan itself. So I'm going to hit yes to let it correct whatever problem it found. Probably just a small point on the underside where I had that block out. But from here, we're finished with our design, and in our example today, I'm going to take this to a printing program. The one I'm using today is going to be from Asiga, but this workflow is very similar regardless of what printer you're working from. The main differences are some of the settings and orientations can vary from material to material. So for example, the material I'm working with today for the example is Flexera, and I've downloaded this instructions for use document from Desktop Health, who makes Flexera. And this has instructions on what types of units this material is capable of working with, how you handle the material prior to printing, how the design needs to be, what you need for post-processing, and it includes some details like what support structures you can create. The one in particular that I want to look at before I nest the file is there's a setting where some people prefer having these mostly vertically placed. Other materials are okay with that, being mostly horizontal for the position of the base. So I just needed to know that ahead of time. For the Asiga program, I'm going to start a new job. I don't have a physical printer at my office, so I'm just going to select a virtual one. We'll use the Asiga Ultra. And for material settings, Asiga has a page on their website where you can download hundreds of material settings from a variety of manufacturers. But the options that you have may vary a little bit for certain printers. In this case, I'll choose the Flexera Base Pink. Our layer thickness is our main control for how quick versus how accurate our printing is going to be. For denture bases and partial bases, I'm usually okay with that printing faster under this 100 micron setting. But for smaller objects with more teeth anatomy, I'm going to print those at a smaller value like 0.05. We've got our print platform. Inside the printer itself, this is upside down, so our units will be hanging from that when the printing is done. I'm going to grab those files. In this case, I've got them on my desktop in this folder. But for 3Shape, it's typically the manufacturing directory where everything's saved. The software does try to identify what type of unit it is, so it tries to auto-place it appropriately, but because it varies a little bit by manufacturer, it might be using Asiga's default setting to have flat partial bases. But in this case, I'm just going to tilt this myself. It didn't look like they have a specific requirement for this, but some manufacturers will even go so far as to say you need it at a very specific angle So you'd take a look and see, let's say they said to have it at 60 degrees vertical, you tilt it to that value. In this case, I just need it vertical enough that it's mostly straight up and down, but not so far that I can't see most of the edges from this underside view, since the edges are where we're going to be putting the supports for this. So I still need it slightly tilted, not completely straight up and down. Especially the clasps themselves, I don't want those overhanging another part of the object. So to add those supports, we can go to this button here. Um, because this type of object has so many different spots we want to try to maintain for fit, we're going to be manually placing the supports. But for some materials, it is okay to some types of units like models or denture bases, full denture bases. You can start off by using the automatic apply to have it automatically generate a lot of the supports. Oh, I might need to restart since I'm 1 second. Let me close out. Realized there was a setting I had changed earlier where I need to restart the software. My apologies. But we'll just open that job from a second ago and we'll go to add our supports. So if you're going to have that apply automatically, it just applies everywhere it thinks it needs a support. And unfortunately, that does not pay attention to specific areas we're trying to protect. So that's why we aren't going to be doing this for most of these types of flex partials. For the supports, I typically am going to look at this from a perfect underside view, since that's the only area where a support can be touching. And I'm going to go to this add button and just start clicking all around the edges of our base. How many supports and how thick these needs to be will vary from material to material. So as with, I know I've been kind of beating a dead horse with it, but as with everything with printing, we need to be super specific to what the manufacturer requires. So we're always going to double check the instructions from that manufacturer. Anything that goes in a patient's mouth needed to be FDA cleared with a very specific procedure, all the way from design to printing and manufacturing. But at this point, after I go around and add all my supports, I'll add them to the edges and to any other potential low points or weak points, like the tips of clasps if I hadn't already, and to the support bars that are running on the pallet side. But after that, we'd be done with the nesting and we'd send it over to the printer. And those final send options will just vary quite a bit from manufacturer to manufacturer. But at this point, we're finishing up. Definitely, if you haven't already, go ahead and jot down any questions you have, all the way from design to printing. I've still got the design open, so we can go back and take a look at anything if you had a question that we passed earlier. But after
Everything
I,
great.
Mhm. But yeah, so again, just to finish up this, for the Asigo, there's just a print button with some extra options you can choose before it uploads it to the printer itself. For anyone who does have an Asiga, I will mention it is okay to use fast print mode, but you should always have separation detect off for pretty much all intraoral materials. But after this, we'd upload to the printer, get the resin ready, and get that on its way. Exactly how long it takes will vary, but both by material to material and by how large the object is you're printing. But yeah, so again, let me take a look, see if I have access to that questions page.
So if you have any questions, please jot them into the Q&A section and we'll be happy to answer any questions that you have. We do have a poll coming up. Alex wanted to know basically, if you wouldn't mind answering this, if you design in-house or if you outsource. Seems like a lot of people are designing in-house, which is great.
Yeah.
But some are outsourcing. Something like this, if you want to start really learning and maybe, you want to kind of master it before you start designing this on your own, you could always refer to Henry Schein Prosthetic Design Services for your outsourcing needs. And you know what? If you have any questions on that, you can always contact myself. You can contact Alex. We'll get you in touch with our coworker, Carol, who oversees that division. So, we definitely do have that option for you. It looks like 68% of our customers, Alex, are designing in-house, but 32% are outsourcing.
Okay.
So, you know, take a look at Henry Schein Prosthetic Design Services. I mean, the pricing is fantastic and they're quick. They're quick
Oh
at
yeah.
those designs to you.
Yeah. Even though these designs are right now at least too complex for any of the AI companies to produce,
Mhm.
our design services team is very good about getting these at a reasonable turnaround time for you.
Absolutely. And then we also have, if you're interested in 3Shape, I would be giving you a call and we can discuss it. So if you're interested, just say yes, and I can give you a call probably sometime tomorrow. And we can discuss how to get 3Shape into your laboratory. And my name is Fran, so that's who'll be calling you. I just want to let you know a little bit about what's up next on Zahn Academy. So on January 21st, Jimmy Stegall is going to be joining us. And this is pretty exciting. He's going to be speaking about Pack Dense BioArch, which is the flexible resin from Pacdent to create these RDPs. So that's you don't want to miss that. We did the design. Now we're going to talk about the materials and actually the printing. And that will be on January 21st. Want to talk to you a little bit about Lab Day Chicago because that's on everybody's mind. So excited. We've been putting together a great lineup for everybody to enjoy. And it's 3 days of education. And Alex is going to be there. He'll be there on Thursday, February 19th. He's going to have a table clinic that's going to be hands-on for 3Shape denture design workflow. And I know, Alex, I know you got a lot of shortcuts and a lot of tips and tricks for our customers. And listen, if you're going and you want to pick his brain about the RDPs, he's there and he'll be on the floor probably the whole 3 days, right, Alex?
Yeah, definitely.
Yep. So we're going to have a ton of education there. Friday is going to be dedicated to business courses. So if you're a lab owner and you want to learn about, a lot of cool things from a lot of different lab owners that are really successful and want to share, their knowledge and their expertise and their successes and their downfalls and basically, how they pick themselves up and you know wind up becoming very, very successful, like I said, join us on Friday for these business courses. We're going to have a ton of speakers like Dan Alter, Paolo Lubrano, Mandy Arena, John Madden, Dora Rodriguez. We have Enrico Romano and Milos Markovic, Brandon Smith, Don Albensi, and Jay Collins, just to name a few. I mean, we have education, whether it be a table clinic or in our glass classroom, going all day long, Thursday, Friday, and Saturday. And we really hope you join us. It's going to be great. Erica and I will be there. And, this is what we love to do. So sign up, go to lmt.com and sign up for some of our courses. We'd love to have you. Alex, thank you so much for this, great lecture, this great demonstration. Can't thank you enough. And I thank all of you for joining us here on our first education series of 2026. We wish you a happy and healthy, successful year, and I hope that you'll join me on January 21st. Have a great day, everybody. Oh, wait, I think we have a question. Hold up.
Oh, okay.
Oh,
Pause the
Darren.
presses. Oh, thank
Darren
you.
wants to say thank you. So, no, we thank you, Darren. If anybody has any questions, you can go to Zahn Dental, and basically, send us a question. You can email me. No big
Yeah,
deal. We'll get the
if you
questions
wanna
over.
If you had any specific things you want to discuss, not on a public webinar setting, feel free to email at the Zahn support at henryshine.com and just put attention to Alex, and we can set up a time to talk over anything you want to.